Alright, we just wanted to do a little video to show people how to do binary addition and explain a little bit about the binary number system. I'll try and keep it short though. With the base 10, the decimal number system or denary, it's called base 10 because there are 10 possible digits in any one column. So you can have a 0 and the numbers 1 to 9, so they're 10 in total. Base 10 numbers should have a little 10 to the bottom right of them so the reader knows what base you're talking about. And if you think about it, we know that this number is 9030 because of the position of the digits. So this is 9 lots of 1000 added to 0 hundreds, added to 3 tens, added to 0 units. 9030. This is 11 only because it's 1 lot of 10 added to 1 lot of 1. So that's the sort of structure is exactly the same with binary. But one important thing to remember is with base 10, if a number moves one place to the left, it is a times 10 move. So this 1 worth 1 in this column, but in this column the same digit is worth 10 times as much. If this 3 was to move from the tens one place left, it would be 10 times as much. It would be worth 3 hundreds. And the same for any other numbers apart from 0, of course. Any move to the left one place is a times 10 because it is base 10, and that's why it is. So it'll be similar but different for binary. So if we move a number, like a 1 in this column is worth 1 unit, but a 1 in this column is worth 2 because each move to the left is a times 2 multiplication. And if a 1 in this column is worth 2, if it moves this way, it'll be worth twice as much. It'll be worth 4. So whatever the number base is, you multiply by that amount every time you go one column to the left. This will become more apparent when we do multiplication, but for now we're going to do a bit about addition and subtraction. So base 2, or binary, bi meaning 2, it has 2 possible digits. Instead of 10, as in 0 and 1, 2, 3, 4, 5, 6, 7, 8 and 9, because it's base 2, there's only 2 possible values you can put in any one column, and they are 0 and 1. Base 2 numbers, we should put a little 2 at the bottom right so the reader knows it's binary, because if you covered that 2 up it'd look like 101, but really, because that tells us it's binary, so we say, right, that's 1 lot of 1, no 2s, and 1 lot of 4. 1 and 4 is 5, so that is actually worth 5 in base 10. Binary system still has the radix point. In base 10 it's known as the decimal point, but it is the radix point. So let's have a look. What's this number worth? It looks like 1010, but of course it's base 2, so it's just worth 1 lot of 8, no 4s, 1 lot of 2, and no units. So 8 and 2, this is actually worth 10 in base 10, but the number in binary is 1010. This number here looks like 11, but of course in binary that means it's 1 lot of 2 added to 1 lot of 1, so that's worth 3. Importantly, the rules for binary addition: 0 plus 1 is of course 1, but people think they can't get their heads around this. 1 plus 1 is 10, but it's not actually 10, it's 10 in binary. And what does this mean? Well, if you've got a 1 and another 1, because we can't put the actual physical digit 2, because the only ones that are allowed are 0 and 1, we need to carry to the next column. So 2 lots of 1 here, actually 1 and 1 is actually in base 10 worth 2, so that means it's 1 lot of 2. And then we fill in the empties. That's where that comes from. And here, if you see it as 1 and 1 and 1 is 3, the way that we represent 3, because we cannot physically write the number 3 in binary, we have to represent it by doing 1 lot of something added to 1 lot of something else. So 1 and 1 and 1 is 3, but 3 in binary is actually made up of a 2 and a unit. So it looks like 11, but it's actually 3 because it's 1 lot of unit and 1 lot of 2. So on. 1 plus 1 plus 1 plus 1, that's obviously 4, but we cannot physically write the number 4 in binary, so we have to represent it using ones. So where do we put the ones? Well, 4 is represented by a 1 digit in the 4s column, and the rest we fill in with zeros as placeholders, the same in base 10. So 0 and 1 is 1. 1 plus 1 is 2. It looks like 10. It's 1 lot of 2 plus 0. 1 and 1 and 1 is 3. 3 is made up of 1 lot of 2 and 1 lot of 1. And 1 and 1 and 1 and 1 is 4, which is made up of 1 lot of 4 and nothing else. So it looks like 100, but it's actually 4. So these rules will come in handy when we do our addition. Alright, so 0 plus 1. Well, actually, let's just find out what these numbers are worth first. This top number is 1 lot of 2 plus 0, so that's 2. The bottom one is 1 lot of 2 plus 1 lot of 1, so that's 3. So if you find the denary or base 10 equivalent, what we're looking at is 2 plus 3, and we should get the equivalent of 5 if it works. So 0 plus 1, look at our rules, we know that that's equal to 1, so we put a 1 there. 1 lot of 2 added to another lot of 2 is 2 lots of 2. 2 lots of 2 is a 4. But we could have just checked our rules that 1 plus 1, it looks like 10. But it's actually carrying 2 2s over into the 4s column. Okay, and now we've got 0 plus 0 plus the carry. So that's no 4s added to no 4s added to 1 4. It's just 1 in the 4s. And then we've got 0 and 0. There's no carry here, so it's 0. So this answer, it looks like 101, but it's actually binary base 2. So it's 101 is worth 5, which is 1 lot of 4 and 1 lot of 1 is 5. Okay, we'll do another example. The numbers that we would expect, that is a 1 lot of 4 plus 1 lot of 2 plus nothing, is 6. The bottom number is 1 lot of 4 plus 1 lot of 2 plus 1 lots of a unit, or 1 lots of 1. 4 and 2 and 1 is 7. So 6 and 7 is 13. So we need to represent 13. So that's what it should come out as. So let's have a go. 0 plus 1, look at your rules, is of course 1. 1 lot of 2 added to 1 lot of 2 is 4. Or look at the rule, 1 and 1, it looks like 10, but it's actually a 1 and a 0. Because of course we cannot put the number 2 here, because the only numbers we can use are 1 and 0. So it carries over to the next column. And now this is the more interesting one, because we've got 1 lot of 4 added to 1 lot of 4 and a carried lot of 4. So some people could say, well, that's 4 plus 4 plus 4 is 12, and 12 is made up of an 8 and a 4. But if you don't want to do it that way, if you just want to see it as 1 plus 1 plus 1, look at the rule. 1 plus 1 plus 1, it looks like 11. It's worth 3 lots of 4, but it looks like 11. So you would write 1 and 1. So that is the answer. So let's check it's right. The answer is 1 lot of 8 added to 1 lot of 4, which is 12, added to 1 lot of 1 is 13. So the system works. So hopefully this has helped a little bit. Any questions or comments you want to make, just get in touch and that's fine. And thanks for listening.